Okay, welcome back everyone. So today marks the start of a pretty nice series, and that's going to be on solving some calculus exams, namely the University of Houston Math Contest, the calculus exam from there. And this is the most recent exam actually. It was from January 30th, 2021. And what the University of Houston Math Contest is it's essentially a series of exams that you can take that high school students and middle school students take, well, depending on the level of the exam. For example, for the calculus exam, only high school students took it. And essentially, there are multiple sections that you can take. So, for example, obviously, this is the calculus section. There's Algebra 1, Algebra 2, Geometry, Statistics, Physics, in fact, and then there's this, number sense section, which is just tons of arithmetic. I would not recommend checking that out, but in general, this competition is very interesting. I just recently found out about it, and I recommend that you check it out. So I'm going to post their contest website in the description below. So if you're interested in looking at some of the exams there, then you're my guest. And let's get started with the first question, shall we? And I would like to add that we're not going to be finishing this whole first exam today. It's fairly long, and well, I want to make these videos fairly bite-sized so they're more accessible to a wider range of audience, namely people who might be busy or don't feel like watching a, 30-minute video. Who knows how long this one will be. This is kind of just the first one to get us started, to see, kind of test things out, right? So let's get started with the first one. So here it is. Let me test out the focusing on this, see if you can see it somewhat well. So here it is. If we are told that the limit as t goes to a of the square root of t minus the square root of a over t minus a equals 2, then the value of a is, and here are options. There are 5 options, and the last option is none of the other answers provided. So that makes this test all that more tricky. But we're not going to worry about that. Okay, so we're given this limit. So limit as t goes to a of fraction square root of t minus the square root of a over t minus a. And we want that to be 2, and what value of t satisfies it? A satisfies this. Okay, well, how do you think we can evaluate this limit? Well, take a look at what happens when you plug in a. We get a 0 over 0 situation. What does that tell us that we can do? Well, L'Hopital's rule. So why don't we differentiate the top and bottom? Well, differentiating the numerator gives us, well, what is the derivative of a constant? It's 0. What is the derivative of square root of t? It's just 1 over 2 square root of t. And the denominator just becomes 1. So in other words, we can just rewrite this as the limit as, t goes to a of 1 over 2 root of t. And we need that to be 2. And notice that this limit, we can simply plug it in with no problems, right? And thus we simply get 1 over 2 root of a equals 2. Well, we multiply both sides by 2 root of a, and we get that 1 has to be equal to 4 root of a. And then simply solving for a using basic algebra, we get that a is equal to 1 over 16, right? We divide both sides by 4 and we square both sides. Okay, and that is option B, as you can see here. Okay, next question. And I like working with a clean slate, so I'm often just going to erase the below even if it's not necessary. Okay, 2. So here it is. Suppose f is a differentiable invertible function whose graph passes through the point 2,5, where the normal line has a slope of -8. What is the slope of the tangent line to the graph of the inverse function y equals f inverse of x at the point 2,5? Okay. Well, what information do we have here? We have that f is differentiable and invertible, and f passes through the graph through the line through the point 2,5. And at that point 2,5, its normal line has a slope, or we'll just say n prime to represent the slope of the normal, has a slope of -8. Okay? And what is the slope of the tangent line to the graph of the inverse function? Y equals f inverse at the point 5, 2. So we want to find the slope of, so basically, let me just write our goal to make this clear. So we want f inverse prime at the point x equals 5, because we're looking at the point in specific 5, 2. So equals what? Okay. And, well, the key here is to kind of use the relationship between two orthogonal lines. Okay? And we'll get to that in a second. But first we want to establish a formula for how we can actually solve for this. And, well, I'll just prove this formula to you right now, because it's fairly trivial. It just involves some chain rule. So let's use the property of an invertible function f. So we know that this property goes something along the lines of f of f inverse of, let's say, some value x outputs x. So in other words, this is the identity function. And the same works the other way around, but we won't worry about that for now. Well, what happens if we differentiate both sides? Well, by chain rule, we'll get f prime of the inside times the derivative of the inside, f inverse prime x equals 1. The derivative of x is 1. The linear function is going to be the coefficient of x. Okay? Well, this is exactly what we want here. So let's divide both sides by this fairly ugly term, but it actually turns out to be nice, very nice in this problem. So in other words, we get that f inverse of prime of x is equal to 1 over f prime of f inverse of x. Done. Okay, well, let's just apply this formula. Okay, so, well, we're looking exactly at the point x equals 5, so why don't we plug that in? When x equals 5, f inverse of 5 is what? Well, we're given that it's 2. So in other words, this becomes 2 when x equals 5. Well, what is f prime of 2? Well, we're given that the normal at f of 2 is -8. Now comes in the relationship between the two orthogonal lines. Well, the slope, what relationship do the slopes have? Well, the line that will be perpendicular to a slope with -8 is going to be the reciprocal of this value. So -1 over -8 equals 1 over 8. There we go. Now we have all the information we need. We get that this is literally just 8. Our answer. Okay? And there's actually a bit more of a less convoluted way to do this, although this is still a nice way. And I'll leave that to you to find. Okay? And again, this might take a bit of time because I still want to explain it maybe a bit more than I need to. And again, it's just an experiment so far. Problem 3. Okay, we have a nice little graph here. Now, it's kind of going to be a bit tedious to read off of. So, okay. The graph of the positive function y equals f of x determines a region over the interval 0, 1 that encloses 5 units of area. So that's the figure 1 below. When this area is revolved about the x-axis, the resulting solid encloses 2021 pi units of volume. Ooh. Okay, I'll read it off. I'll read the rest off. How much volume is enclosed by the solid of revolution obtained by revolving y equals f of x plus 1 about the x-axis along the interval 0, 1. Okay. Yes, okay. So, well, let's use our first piece of information, namely that that this function y equals f of x determines a region over the interval 0, 1, which encloses 5 units of area, which is just a bit of a complicated way of saying that the integral from 0 to 1 of f of x dx equals 5, right? Since it's a positive function. Okay, so when the region is revolved about the x-axis, the resulting solid encloses 2021 pi units of area. So how do we revolve something about the x-axis? Well, think about our little dx there. We have little infinitesimally thin disks where the length of it as delta x goes to 0 is going to be dx, right? So then we just have, well, we're just going to, and what is the area of a circle? It's pi r squared. And in this case, r is exactly going to be f of x at any point x, right? So in other words, the other piece of information that's, we're rewording it essentially, is that the integral, and we'll take out the pi directly, from 0 to 1 of f of x squared dx is equal to 2021 pi. We can cancel the pi's if you like, although you'll see that this isn't necessarily necessary yet. So we want to find what y equals f of x, what area we get when we rotate y equals f of x plus 1 about the x-axis. Well, let's use this formula, or it's not really a formula in this case, we're kind of intuiting our way to the formula. So in other words, we'll just use a similar idea. We'll get the integral from 0 to 1. Well, what is f of x, what is y in this case? Y is going to be f of x plus 1. So we're going to square that. And let's just directly do this in our head. We get f of x squared plus 2 f of x plus 1 dx. Okay, good. But we already know all of how to resolve all of these. Well, we get that this is equal to pi times large parentheses. Well, what is the integral from 0 to 1 of f of x all squared times pi? Well, we're taking out the pi for now. Well, that's exactly going to be 2021, and that's given to us. What is this? Well, what is the integral from 0 to 1 of f of x? It's exactly 5. What is 2 times 5? Well, that's 10. And finally, what is the integral of 1? It's x, and going from 0 to 1, we'll clearly get 1. So our final answer is going to be 3032 pi. Okay, great. And what answer choice is that? That is answer choice C, I think. Wait. Oh, sorry, this is supposed to be 2. What am I doing? Yep, that's correct. So it is answer choice C, as you can see. Okay, next problem. How much time has elapsed, actually? 13 minutes, wow. Anyway, two particles are moving along the y-axis okay, I should probably show this to you at least. So, let's see, so it's this last problem here. Two particles are moving along the y-axis with position given respectively by, and these two formulas for position. I suppose I'll write them on the board, and then it's asking for, at most, how many distinct points in time do the two particles share the same acceleration. So this is a fairly straightforward problem. It's just some algebra and some derivatives, which is pretty much algebra. Okay, so what are our y1 and y2? Y1 is given to us as usual. Oh, it's in terms of t. It shouldn't really matter. It's t to the 4th over what? T to the 4th over 3 minus 16 t cubed over 3, and then plus 32. Oh, okay, 32 t squared minus t plus 5. Y2 of t equals t cubed over 12, I think. Oh, 5t cubed over 12. T to the 4th, I mean. Minus 20t cubed over what? 3 plus 40t squared plus 5t minus 1. Okay, now let's just try to find the acceleration of both these by taking the derivative twice. So y1, I mean, we could try doing 2 derivatives at the same time. Why not? Okay, first derivative, 4 comes out here, becomes a 3, then a 3 comes out, and we'll actually get something like 4 t squared. Exactly. So now here, well, 3 comes out, cancels already, and we should just get minus 32t. Okay, and this becomes a constant. This becomes 0. This becomes 0. This becomes constant, and that constant is going to exactly be plus 64. Okay, and y2 double prime of t is just going to be equal to, okay, well, let's see. So we'll get nice cancellation there. We'll have 5t squared. Okay, and then we'll have 40 minus 40t. These two become 0, and then we'll have plus 80, if I'm not mistaken. Okay, well now let's set these two equal to each other, and then directly subtract off. Let's see. So actually, yeah, so if we subtract off like that, we should just get t squared, and we're getting a quadratic equation, minus 8t plus 16. Okay, equals 0, which actually just factors nicely as a perfect square, which is t minus 4 squared, if I'm not mistaken. You can check that for yourself. Equals 0, so t equals 4. That only one point where their acceleration is the same. Okay.
Sorry, I'm not sure.
Stop. Sorry about that. Okay. And looking at, oh yeah, we should just do one more maybe. Yeah, we'll do one more, and hopefully I'll try to make it faster next time. Again, it takes like, I don't know, I'm really slow at this, so it takes, I don't know, maybe like 2 minutes and 30 seconds to get set up for every problem, maybe even 3. And also explaining it takes, I don't know, an extra 2 minutes. Okay, on average. So here, we're on the next page now. So we have, for which value of a does the following limit hold? Limit as x goes to 0 of 1 plus x to the a over x equals a. Well, hopefully you can already notice that this looks suspiciously like e on the left-hand side. I'll actually give you a hint, it's one substitution away. So while I'm finagling about with my markers, you can try to solve this one. Actually, theoretically, it should only take a few seconds. So while I write that up, I'm really thinking about maybe live streaming, but I don't have enough viewers. So that is unfortunate. We'll see. Okay. Have you found the substitution yet? The substitution is x equals 1 over u. Why? Well, again, we get something, we get e to something power. Actually, to the a power in this case. Why? Again, well, let's see, so this also implies that u equals 1 over x. As x goes to 0, u goes to infinity. So we have u approaches infinity. Okay, and again, by our substitution, we'll get 1 over 1 plus u to the au power. And this is exactly e to the a, if you need to review some of your basic limits. And we need this to be a. But there's a problem here. This never holds, which you can pretty easily prove by induction, although it's fairly clear from here and we don't really have to prove anything. And The only thing that you might consider is a equals 0 or a equals 1, but no, it's not going to work because when a equals 0, well, anyway, an exponential function never goes to 0. It has a horizontal asymptote at y equals 0. So, yeah, so, nope, this isn't good. So, let's see. Our answer choice, yeah, there's no value of a that makes this equation true, and that is E, as you can hopefully see. Oh, that actually focused really well. Wow. Yeah, I wish this worked for the entire time. Yeah, that's E. Okay. So hopefully you enjoyed this part 1 of the series, and yeah, make sure to check out their course website and the link below, and I'll see you in the next video. Goodbye.